the domain. A domain in a system of coordinates is the distance from the point to the vertical y-axis measured parallel to the horizontal or x-axis, which is called the x-coordinate. The synonyms are the abscissa, which is a word which is at least outdated at the moment. We no longer use it, but we've been using the independent variable, which is also another synonym for the domain. The domain here, here's a land surveyor. They're using the x-axis to measure and get the distances. So now a range. A range is a straight line from any point drawn parallel to one coordinate axis and meeting the other, especially a coordinate measured parallel to the vertical. The synonyms also here is the ordinate, the old one, and also it is called the dependent variable, because the range will always depend on the domain. Representation of functions. Functions can be expressed in many different ways for different purposes, namely verbally. Now, if we say a plumber charges 250 rand for a call out fee and 100 rand per hour thereafter, so that is also a function which can be used. Then mapping diagrams. In mapping diagrams, we have an input, and there's a box. Inside the box, this is where the function is taking place. Maybe which you can say maybe the food is cooked, then the output, which is now the product. So we also use the mapping diagram. This is also another mapping diagram where now we have the numbers. We must also remember that with a domain, an input will always have the x values will correspond with one value of the output, which is that. But we still can have it's a one-to-one or a many-to-one. You can still have two more values, but having one value of y. So which is a many-to-one, which here I didn't have. Also, we can use the table. If we're having the input variable, which is the x-axis, the x values, and the output variables. So that is also another representation of the functions. We can still have also in the form of set of ordered pairs, -3 and 8, 0 and -5, 5 and 0. So we are still representing there the function. Then you can also have it in the form of the algebraic formula. Algebraic formula, the function of x equal to x minus 5. That's also another way of representing a function. Then also we can represent a function using the graphs, which is the graphical representation of the function. So each and on the line here, we can plot the coordinates, the value of x versus the value of y. So like this point, this point is representing a 5 and 0 way. This is the x value and the y value, and on this one, this is the x value and the y value, etc. And this one is the -3 and -8. So these are different ways of representing the functions. Types of algebraic functions. I did not provide for you the trigonometric functions due to some other that is difficulties I had. I also had some hectic day today like you've been having, but we'll talk later, right? Right. So this is types of algebraic functions. We have a linear function, which is done in grade 8 and 9, where now this is called the function of x, which is similar to the y values. So which is equal to y equal to mx plus c, where m is the gradient of this function, and c is where the graph cuts the y-intercept. So what is important for the grade 8 and 9 learners to know is that if m, the m here, if the m is greater than 0, this is telling us that the gradient is positive. Then they should know immediately that the graph will face to the right-hand side. And also if m is less than 0, the gradient is negative. Then the graph will face to the left. This is very important to mention. That is now, if I'm teaching grade 10 and 11, it is important for me to establish first whether the learners do have this basic background of the linear function which they dealt with in their previous grades. Then we also have the quadratic functions. So the quadratic functions can be represented in 4 different ways. That is f at x equal to ax squared plus q, and f at x equal to ax squared plus bx plus c, and have f at x equal to a into x minus p to the exponent 2 plus q, right? And also this was just a bonus one, f at x equal to a into x minus x1 into x minus x2. So you should know each one of these, when do we use this and how do we use them? So I'm going to come back and just draw these graphs using the GeoGebra. Let me just look at the third one. The third one is the hyperbolic function. The hyperbolic function, the mother hyperbolic function is y equal to a over x. Then the sister functions will be y equal to a over x plus q. And the third one is y equal to a over x minus p plus q. So we'll see how these vary when we embark on the GeoGebra. The fourth one, what is happening to my screen now? What is happening? Let me just go back. Oh, it looks like I've lost something here. Okay, but all the same, I was having the which one is that which is missing? Oh yeah, the exponential one. The exponential one is y equal to a to the exponent x. That is the mother function. Let me just write this one down because it's gone missing. I know what happened. I typed it, and yet I had this on the stick. The one which I'm presenting on now was on the stick. So if I can just go back here, just a minute. Can you, Tal, can you please take me back to, or let me just stop sharing here so it's like I can have another thing to share with you that is on what I've typed.
Okay.
Yeah, no, but I need to see my taskbar for my other functions, because I need to connect my tablet here to write on. You see, I'm having it here, but Yeah, I don't. Okay, that's
Sounds
it. That's
very
it.
fancy.
Yeah,
You
that's
got
it.
it.
It is here now.
Okay,
So,
great, great,
so
great.
let me just check here if uh, I do have it. Let's find out. Okay, I know it was not here. Maybe I put it on another. Okay, it should be here. Oh yes, should be here. Right. The exponential function y equal to a to the exponent x for all a elements of real numbers. And it is important to mention to learners that a should always be greater than 0 and a should not be equal to 1. And also this is the mother function, and y equal to a to the exponent x minus p plus q. And also we can have y equal to a to the exponent uh, negative a. If I can come back to this other one, then and check if now we can do these functions. If we can do these functions using the GeoGebra. So let me just share with you my GeoGebra Classic here. So if I can type now y equal to ax, the exponent of 2 plus q. Oh, sorry, missing a plus here. Plus q, and have and enter. Okay, enter. Right. So this is the function that I have already. It is giving me the sliders. I was going to put them maybe because I've been using this today. So now let's look at the behavior of the function when now we're changing a. So if we're changing a, so if a is becoming smaller and smaller, the graph is becoming wide open. Wide open. Let's see if now our a is equal to 0. You see now if a is equal to 0, if a is equal to 0, my graph is just, I mean, the function is just horizontal, right? But now if I go extreme left, then now my function bends. It is facing down, which the learners must also know. That is, if a is negative, my function is going to face downward. If my a is positive, if my a is positive, then my function is going to face upward. Then if I'm increasing my a, see what when I'm increasing my a, it is becoming it closes down. Oh man, this thing is giving me a problem. Okay, it is becoming smaller and smaller. Okay, okay. You see now, if my a is increasing, the graph is closing down, it's closing down, closing down. If it is decreasing, it opens up until it becomes 0. So now let's see what is happening if now we're changing q. So this is my function. So we can make your reference with that function, what is happening to it. If I'm increasing q, look at what is happening. My function is moving upward. It is moving upward. If I'm decreasing my q, the function is moving downward. Right. So that is the function of a x squared plus q. Now let us look at this one. This is very interesting. Where now I'll be having a b. So if I'm now, I go back to my screen there. Let me just remove all this. We just remove all this so that we start afresh. We get another function. So if we have y equal to ax squared plus bx plus c, right? So I need to add another slider here, which is a c. We just let me add a slider here. Okay, just enter and see. Okay, no, let me have a real equation here. Let me just remove an a and put a number, a constant like 2 plus, which is, this is our b, plus 3x plus maybe plus 2, right? So this is our function. So also this is very important. If now our function is just above our x-axis, which means that we don't have the roots. No, not that we don't have them, but they're imaginary. They're imaginary. Let's see now if let me have the sliders here. Okay, let me just have the slider. A equal to 1. Okay, that is fine. And another one, B. Okay, that's fine. And let's have another, or C, that's fine. But this is 1 on 1. Okay, if now, let me just remove this here. Let me remove these here. Okay, so let I move this one. So look at this. If now I'm increasing my A to still remember that what is going on now? Okay, let me use this one. Oh, but you can help me here. This is not responding well. Let me just check with my P. Or maybe, okay.
Les, can I come in?
Yes, sure. Let me,
yeah, delete all these sliders.
yeah. Okay, let me check now.
No, delete all of them.
All of them, okay. Okay.
Make your equation ax squared plus bx plus c.
Ax, okay. Oh yeah, that is why it is getting confused. Okay, sure. So the first one was fine. So I made it wrong. Okay, plus C.
Bx plus c.
Thank you, Pata. Bx plus C. Right.
And then you go to there to sliders. Yeah, click there.
Okay.
Yeah. Yes. Okay. Go again there.
And B, okay. Let me just put it on the side. I'm sorry, my mouse is a bit sticky. I don't know if it is getting naughty. Okay, so let's check what. Okay, still, man. Let me move this one. Let me just remove this. My function is not responding. Okay, let me say enter. See.
Let's
Yes.
delete this function. This one should go this one.
Yeah, let me just.
Click on this one and
Okay.
delete it. This one, this is here, this existing one. Delete this one.
This one. Right.
Delete.
Let me write the equation now. Okay, let's try AX.
Y equal.
Oh. Y equal to AX squared. This space is gonna give me a problem, okay? So it's A X squared plus BX plus C. Then let me have the sliders. Okay, here are my sliders. Okay, let's now try and see if this is going to respond. Let's see if we're moving an A or yes now. That's wonderful. So now if we've already done this one, but let us check if now we're moving a B. You see if a B is making another parabola and making a change at +1. So which means that it is not going to change because our y-intercept is +1. So always it is going to pass at +1. So let's do it again. You see if I'm decreasing it, it remains there and it is sticking at +1 because that is the y-intercept. This is where the graph is going to go through. Let's see what happens if we are changing the y-intercept. So if we're checking if the y-intercept, it goes up and down. If I'm decreasing it, the y-intercept, I mean the function is moving down, but also it is no, it is not opening up. It remains in its own original shape. So this is how we can explain. Whilst we're explaining, we can also use the GeoGebra to show that the letters how the parameters affect the particular function. Let's look at another one. Okay. So let's check this one. Y equal to that. Let's go back to this function. Let us remove all this so that it doesn't get onto our way. Right. So let's just have y equal to a into x minus p squared plus q. Right. Plus q. They enter. Then let us have the sliders. P and Q, okay. And A also, I should think we must also have a slider for A. Slider for A. Sorry. Okay, this is a slider for A. Okay, now let's say enter and see. This is that is the function which is described by that one. If A is equal to 1, P is also 1 and Q is 1. Now let's also explore what is going to happen if we're changing P. What is the effect of P on the function? So our P is going to make our function move If we're moving to the right, if we're increasing the value of P, the function is going to shift to the right. If we're decreasing the value of P, the function is shifting to the left. So learners must know that the P affects the function to move to the left and to the right. Let's see what is the effect of Q. If we're increasing the value of Q, the function is moving upward. If we're decreasing the value of Q, the function is moving downward. It's very, very interesting for learners to know. I think if they can see this magic, they will never forget. They will never forget it. Okay, now let us look at the behavior of A. I should think also that now if the learners have learned about that previous equation, automatically they should make an association of these of these different functions. Okay, let's see. Okay, we saw that one. Let's just see what is happening if we're in decreasing our A. If A is becoming more negative, let us move this function a little bit upward so that we have our our roots. Okay, so this is how this these parameters affect our functions. Okay, so there's always a question which is there, which is asking the learners, but let's reserve that. Maybe we're going to do that when we're doing the exercise. Okay. Now also, if we go back to the next type of function, the hyperbolic function, I'm going to give that is the function y equal to a over x. Let's remove this first. Okay. Okay, let's remove everything so that we work with a clean screen. Right. So if we have y equal to a over x, and let us say enter. So if we have this is the mother function. Now you see that if a is positive, always the function will be on the first quadrant and the third quadrant. And the learners should know that is now this will always be the case. That is now if we have a being positive, the function is going to fall between on the first quadrant and the second quadrant. Let's see what is happening if we increase now our A. If we increase our A, this is what is happening. It moves away from the from the origin. The function is moving away from the origin, but it sticks on the first quadrant and third quadrant. Now let's see what is going to happen if now A is decreasing. If our A is decreasing, so it's coming closer and closer to the origin, and all of a sudden it gets into the second quadrant and the fourth quadrant. So learners will grasp their content very easily if we can try to use these mathematical what is it? These maths materials which are provided to us free on the on our online. They're given free online, so you can get your GeoGebra free online. You can download it, then you'll be able to use it in that particular fashion. Well, I'm still not an expert on it, but I've just mastered these few things which I'm doing now. Okay, so that is important. And also what is important with this function is that if we draw the graph of, let me just have another graph of y equal to x. So you see that the y equal to x becomes the line of symmetry on this function. It will always remain for this particular one. It is going to be the what is it, the axis of symmetry. Now let us now have a different equation, that is y equal to a over x minus p. So sorry, should be a capital letter P, x minus p plus q. And let's see what is going to happen. Let us add another slider here, which we don't have. Let us remove this one. Oh, yeah, okay. We have now a P, we have a Q. Okay, let's just enter this and see what is going to happen. Okay, no, it doesn't want this mess here. Let me just remove these things which are not needed here. We clean up, okay. And also we have a D, we don't have a D in our equation. We rewrite the equation again. It's y equal to a over x minus p plus q. Enter. So you see that if now we're having this particular equation a over x minus p, the p is going to give us, I mean, the function is going to change in a certain, behave in a certain way if we interfere with the p. Let's see what is the effect of p on this function. If we're increasing the value of p, so our function is going to shift to the right. And also if we shift it to the left, it is shifting towards when p is shifting to is decreasing, the function is shifting to the left. Let me use the term. If p is increasing, it is shifting to the right, but it maintains its shape. What is happening if we interfere with the q? If q is increasing, the function is moving upward, but it is maintaining its shape. Also decreasing it, it is shifting downward. Okay, so this is what is happening all the time when we are interfering with it. Now, this for a change, just decrease A and see what is going to happen. So this is what is happening. It is it is going towards the second quadrant and the fourth quadrant. So these are also the basic things that we need to teach to our learners, so that it becomes, they don't get tempted to memorize, but they've seen things happening in front of them. Okay, let's do the last one now, the exponential function. The exponential function, I know that one is on another screen. Okay, let me just remove this. Okay, yeah. This is what I'm looking for. Okay, it doesn't allow me to do that. Okay, let's just look at the exponential function. With exponential function, we said y is equal to a to the exponent x. For all values of x, elements of real numbers, and a should not be, should be greater than 0. A should be greater than 0, and a should not be equal to 1. We'll check the a is equal to 1, what is happening. And also, y equal to, my mouse is misbehaving here, it's very sticky. Okay, let me just go to our GeoGebra page and remove all that and clean up the space here so that we have sufficient space for dancing. Right, so y, if we have a function of y equal to a exponent x. Okay, with this one, let's see if I increase the, okay, here we have to, we will change the, let's say enter. No. This thing is let's say x equal to 1. What is going to happen here? Let me just have another function here, which is y equal to a exponent x minus p, at least. Let me try that one. Plus q. Okay. Is there something wrong here? Or y equal to, okay, this is not an exponent plus that. Oh, it's, I'm sorry there, I've just written my equation wrongly. It is y equal to a exponent x minus p. Okay, it's better if I do that one. Plus q. Let's see. Enter. Okay, let me just change my a. My a should be a value at least. Should be a value. I'm sorry about that. I remember now that.
No, leave it as it is less. Just try and see what happens if you change your value of a.
Pardon?
Try and see what happens if you slide in a, because there it's horizontal now. Or try on a slider to change a on a slider.
Oh yes, oh yes.
Leave it as a and then change to a slider.
Let me just do that.
Leave it a here.
Oh, I'm deleting the wrong. Oh, let me just retype it. Y equal to a exponent x minus p plus q. Oh, okay, yeah. Let me just increase a. If I'm increasing a, oh yes, it is. Yes. You see what we learn on the way. Thank you so much, Pata. Right, so this is what is happening. If now we increase the a, let us decrease. Let's say we said a should not be negative. Let's see what is going to happen if now we make a negative. What sort of umsangano is going to happen? What is happening? So it disappears. So a should always be greater than 0. Should be greater than 0. So I think that practically, if we do this with the learners, then they will have a reason, or maybe they will have an understanding as to what really happens if A is less than 0, or A equal to 1. A equal to 1, it becomes flat. So let's see what is happening if A, if P is increasing. If P is increasing, our function is moving away from the original, from the point of origin. Sorry, from the point of origin. And also, if let us make a P negative in C. If P is coming more and more negative, our function goes like that, like that, like that. It is becoming flat and flat if our P is decreasing. Let's look at what happens with the Q. So all these Q, if we are increasing the Q, the function is moving upward. So the learners will begin to see the common properties with all these functions. So now it is very important for us maybe to give the learners some projects, or maybe the projects where they can explore these things. If you don't have the GeoGebra, or maybe you don't have a screen at your school, you can just give them that is a graph paper or graph book, and give them different equations. So they draw. Our learners now are not given an opportunity to draw. To draw. They're not given the opportunity. Like also, they're always given the diagrams drawn for them, and they just work on them. Right. Let me just continue here. Tal, I think I'll call you now just to work on your calculator, using my functions. Can you do that?
Sure, absolutely, Themba, no problem.
Okay, please.
You just tell me what you need.
Let's take this one. Let's take. I saw that it comes very handy. Okay. It was this one, was this one, or it wasn't this one. No. Yeah, let's do the exponential one, Tal.
Sure,
Exponential one.
Do you want to play with the calculator with the exponential one?
Yes, please.
Okay.
Can you do that so that you, because you're on the top with the calculator.
Sure, no problem.
Okay.
Okay, guys. So I'm going to share my calculator with you. This is actually a question for the financial maths on Saturday. So if we want to look at a function and we're looking at hyperbolas, right? What we're going to do is use table 2. So mode table 2. So I'm just going to press 2. And let's just start with the basic one. So we have y is equal to a over x, right? So what you do is you don't put your y into the table, you just put the other side of the equal sign. So let's make our a 5, and we're going to put it over x, just like that. And we're going to say equals, and I'm going to ignore function 2 for now. I'll come back to it in a little bit. And then let's go through the steps. So here you can see your asymptote, because anything divided by 0 is undefined. So you cannot actually have a value or a graph at that point. Okay, if we go up your table, you'll see there are all your matching coordinate pairs. And of course, your table is unlimited. So you can make your x value as big or as small as you like. and you won't run out of space. And then of course you can go back and plot these values as well. Now if you look, if we went in both directions, as your X value gets bigger, or more negative, for lack of a better way of putting it, your Y values get smaller and smaller and smaller. So you can see that they are tending towards, that's the fancy maths word for becoming more and more like the y-axis. Okay, so that's more and more 0. Okay, and you'll see the more I go down, the closer it gets to 0. Okay, now if I leave this one here and say, for example, on this one, I put 5 over, sorry, I put 5 over x and I say minus 2. Now what's going to happen? Okay, I'm just going to equals again, and you can see here that all of your values have shifted across by 2. Okay, so that's what's happening here, the values on your x values, if you look. So when x is 2, the first one is 2.5, but my second one is 2.5 at 4, so it's jumped by 2. So it has shifted positive 2 on the x-axis. In other words, it's shifted over to the right, okay? That's when I do a minus. Now, if I do a plus, so I'm just going to go back here and say plus 2x again. So guys, you can, this will help you with drawing graphs, and particularly if you don't have a nice projector in your classroom. If you have your kids all doing this on the calculator and drawing the graphs, and exploring the difference between the two. So here you'll see 2.5 for answer 1 is at 2, but for answer 2 it's at 0. So here it's shifted 2 to the left-hand side, or to the negative side. So that's what the difference is when you add or subtract a 2. Now if I add a plus q, so I'm just going to change function 2 here. I'm going to say 5 over x, and I'm going to say plus 1. And now when I look at my graph here, all of my values have just gone up by 1. Do you see? So here they're all the same plus 1. So it's just answer 1 plus an extra 1. And if I look this side, plus an extra 1. Do you see? So here your graph has just shifted up because we've added an extra 1 to the value. Okay. And again, you'll see now your asymptote will still stay at 0, but your graph will tend towards 1 and not towards 0. Do you see as we go here? It will just keep going towards 1 the whole time. And if I go down the other side, what's going to happen is I'm going to keep going towards 1 and not towards 0. Do you see? Same. So that's what an asymptote will look like when you're looking for your y asymptote. And the more you click, because your table is unlimited, we can do this for days, the closer you'll get to 1. So eventually on the calculator, because you only have 9 working digits, eventually what it will look like is just 1 or just 0. I just want to show you this. Just because it's so interesting. I think it's going to take me 40 years. But seriously, it's a really great exercise to show your students. It's something interesting. And they can go and test you, because what you're proving to them is that this value in both of these columns is never going to get to 0 and is never going to get to 1. And that is the whole point of an asymptote. Okay. Themba, you good? Can I pass it back to you?
Okay. Thank you, Tal. Just bring my screen back, please.
Themba, you just need to reshare your screen.
Okay. Thank you.
No problem.
Yeah. Okay. Now this is just to one exercise here. Okay. Let me just take this one out. Oh. Okay. Tal, I don't have my icons here. Or let me just stop sharing with this one and see. Yeah, can you bring my task bars at the bottom here? I don't have them on my screen. screen.
Themba, just share your screen and then escape out of your PowerPoint presentation. Then you'll be able to see your taskbars.
Okay.
While you're looking for that, Thokozani has said quite an interesting statement. So he agrees that the turning point is a negative or a maximum, etc., etc. But you should rather let the learners investigate instead of telling them themselves.
Investigate it, yes, I saw that one, yeah. Thanks, Thokozani. Yeah, this is why I was saying the teachers should give the learners maybe some sort of a project or maybe an assignment so that they investigate it. And also we must go back to using the graph paper so that they just do it manually. When you do it, maybe using the GeoGebra and other instruments, then it's just going to be a confirmation. But they should see what is happening if you're doing if A is increasing or decreasing, something like that. Let me just check also again here. Really, my screen here doesn't have.
Just press your escape button, Themba.
Escape button.
Yeah.
Okay. Let me just go up here. Let me stop sharing this one and see.
Share your other version of that one.
And the problem is here at the bottom. I don't have any other thing. Let me exit full screen and see. Still, oh yeah, now. Okay, sure. Now I'm okay. Let me just
great.
Yeah. Let me just go back here. Or maybe let me use this one. Right. So this is the exercise that maybe we can just play around with. And I know
we can't see your screen. You just need to share that with us, yeah.
Okay, let me just go back to share. Why are you not seeing my screen that side?
Just click on the screen if you want to share. And then say share.
Oh, yes.
Should come up here.
Okay. And let me share with you. Share. Okay, can you see now my screen?
Yes.
Yeah. Okay. So here is a question. It's a grade 10 one, a grade 10 question. But just for us, just to exercise our brains a little bit. So the diagram shows the graph of g at x plus ax cube plus, ax squared plus q, and fx equal to mx plus c. R and s are the points. S equal to among the coordinates of S2 and 0 are the x-intercepts of G. And T at 0 and 8 is the y-intercept of G. The graph F passes through R and T. So this is our graph F, which is passing through R and T. And this is our graph G, which passes through T and S like that. So let's just look at the underlying questions there. Let me just reduce this and pull the questions aside. Okay. Now the questions are write down the range of G. So now the learners should be in a should be able to. We should be able to define the range, and also they should be in a position to identify it on a given function. Let me just push this a little bit there so that I stretch this one a little bit. I think it is big enough now. Okay, the range of G This is function G. My G has just disappeared. Who can just give us the range of G?
Guys, you can answer in the chat. I think that'll be
Yes.
the easiest way. If anyone
On
wants to
the
give the
chat.
answer.
Okay. Let me just check my chat here. They can give us on chat. Let me just remove this. Write down the range of G, write down the X coordinates of R, and calculate the value of A and Q. Okay, let's just do 5.1 up to 5.4 first before I check the chat there. Let me see if there are any responses on chat. Oh.
Diego, yes, please answer on the chat panel. That's the perfect spot.
Come again, Tal. What do you say?
One of the attendees is asking if they answer on the chat. So if you guys want to type your answer into the chat and let us know what you think answer to 5.1 is. Or otherwise write them down and see if you write with Themba. How do you want to do it, Themba?
Okay. All right. Check my pad. Okay. Okay. The range, which from this point downward. So it will be y, an element of real numbers, such that y is no, yes, y is an element of that, and then that is starting from 8. 8 is there, all the values from 8 up to negative infinity. So where 8 is included up to negative infinity, but we don't know the value of infinity. I should think that that should be the correct answer for our G. It is decreasing all the way, down, but it starts from y equal to 8. So 8 included also. Let me just check my chat also. I can't see my chat on here just to check other answers. Okay, let's look at 5.2. 5.2, the coordinates of R, then as I've said, so we have another value of X here, another value of X here. So the distance between these, because we can see that the function cuts at X equal to 0. So obviously this is the axis of symmetry. So which means that this value is going to be -2 and 0. So our X value there is -2. X is -2. Right. Then say calculate the value of A and Q. The value of A and Q. Now we know that, oh, okay, the y-intercept, we have the y-intercept there, which is our C, and also C is equal to 8, and the gradient, we can easily calculate the gradient, but do we need that for now? Let's see. We have a value here, S equal to 2 and 0. We have R equal to 2 and that. We know that if we have, we have everything here, because sometimes we can be given a turning point and any other any other point, then it is easy for us to find the equation. And also, if we can be given 2 points on the function. Now we found this value and that value. So we can use either y equal to a into x minus p all squared plus what is it? Or plus q. So q is q and c is the same. The value of c is the same as the value of q. So we can take any other point. Take any point here, like the coordinates of the turning point are this one. So P is the value of of X at the turning point, and Q is the value of Y at the turning point. Sorry, the value of Y at the turning point. So we can take any other point here. Let's take the one which was given to us, so that we are safe. So we can say y is equal to 0, which is 0 equal to okay, is equal to a. A is what we're looking for. Sorry, my writing here is becoming bad. Okay, and x. Let us take any value of x, like 2. Let's use this point s. So it is 2 minus 2 minus what is the value of x at the turning point? Is 0. So 2 minus 0 squared plus q. Q is 8, isn't it? Oh yeah, q is 8. So then therefore we can have this equation, which is let's get another. Oh no, let me squeeze it here. So it is going to be negative 8 equal to 4a, which implies that a will be equal to negative 2. So we can find a. Just playing around with this equation here. If you transpose that is negative 8, blah blah blah. If you did it here, so it's 4a equal to negative 8. So a is equal to 2 negative 2. So we have the value of a. A is 2. Let us now, q we just found it, and q is equal to 8. So this exercise is very good, just to give your learners questions which they can work out very easily, so that they get encouraged. We don't just at the beginning just give them difficult examples. So what is the equation of f? The equation of f now, we can let us use this one. Yeah, this is f at x is equal to mx plus 8. We know now the value of c is 8. All right, take any point on this one. We can still use, let's use the one that we discovered on our own. So now, which implies that our y is 0. Let me just write it the other way around. Mx plus 8 equal to f at x. So our y is 0. Y equal to 0, and m is unknown. Our x is negative 2. Is negative 2 plus 8. So which implies that minus 2m will be equal to minus 8. Therefore, m will be equal to 4. So just for the learners to get motivated, just give them something which is simple for them to calculate. Okay, so the function now, the function of that is going to be, because we're looking at the equation is going to be y equal to 4x. Let me see. Yeah, it's equal to 4x plus 8. So that is going to be the equation of f. Now they also say here, use the graphs to determine the values of x for which f at x is equal to g at x. You know, with this one we can equate the two graphs. F at x equal to that. So where are these two graphs equal? They're equal at this point. At that point. By the way, what is the question? Oh, use the graph to determine the values of x for which f at x is equal to that. So they are equal at this point and also at this point where they coincide, where they cross each other. So the values of x we know that is going to be 0 and -2. So it becomes easy for our learners. Use the graph to determine the values of x for which f at x is equal to that one. So what is g at x times g at x? Or use the graphs to determine the values of x for which x times g at x is less than 0, right? With that, let's see what is going to. Can you please work this one out, please? X times g at x less or equal to 0. And let's see what you get there. Let's remove this. Tal, please
Yes,
give me
Themba.
give me my chat back. I don't have it on my
I
taskbar.
don't know why it's not showing up on your chat.
I don't know.
There's no
See,
answers there.
I have here participants, question and answer, polls, new shape, polls,
Okay,
and that
go
are not
to
let,
more.
let me press those three dots. Let me check on
Yes,
those three dots.
that's the
Uh,
one.
Okay, let me just go back to it. Blah, blah, blah. Though still on the three dots, I have record, meeting info, disabled participants, blah, 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 and then leave. So still, I don't have, I don't know what's going on with this screen.
Themba, try pressing Alt
I've got,
H.
ah,
Alt and H. See if that works for you.
Alt and H.
Yeah. Did your chat come up? You got to press them together.
Okay, no, oh, did you send something here? Let's see.
No.
Okay, no, no, I'm failing really. I don't have it here. Okay, because I wanted to check on the solution there, but I think because this was just a demo lessons, you can work all these other the last two later on. Tyler, can I throw this can I give you an opportunity just to wrap up?
Sure.
What's the time now? Yeah.
Sure, I think it's close to 9. It's 5 to 9.
Yeah.
Okay,
Yeah.
awesome. I'm gonna share my screen here quickly.
Okay, sure.
Oopsie. You see, I was really asleep when I did this. So guys, this entire workshop has been in aid of the Future Fund 2.0. What we're doing is trying to raise money for calculators for students who cannot afford their own calculators. And as you've seen, a calculator is an absolutely critical piece of equipment to do maths. You're all here, you all know this, and we just want to give kids who don't have access to these sorts of opportunities at least something to help them through the exams. If you look at a matric final paper, 25% of that exam comes down to whether or not you know how to use the calculator. That's a huge amount of paper. That's a quarter of your paper down to whether or not you have a tool that you can actually use. It's frightening. So if you would like to donate, I actually haven't got the donation link in the chat, but I will send it in the email tomorrow. So please donate through Zapper. And every donation that you make, Sharp will match your donation. Okay, so if you donate one calculator, we will match it with a second calculator for you. So I think it's a really exciting opportunity to help students and milk a big corporate. I'm just kidding, we're not big, okay? But yes, so thank you very, very much for joining us. Remember that there are free worksheets available on Maths at Sharp. I'm gonna pop that into, where's my meeting gone? Oh, sorry guys, I suddenly had a moment where I thought I wasn't chatting anymore. My apologies. So I'll pop this maths@sharp.co.za into your chat function, and you can go and get free worksheets off there. There are worksheets for grade 10 and 11 functions. If you struggle to download them, just send me a mail. I'll happily send them to you with the memos. Remember that the core thing with maths is practice, practice, practice. And then thank you very, very much to Themba from CASME, who has put in so much effort and time into doing this functions workshop with us. We really do appreciate it, Themba, and we hope that you as the teachers and students have found it helpful. I will be doing financial maths on Saturday morning at 9 if you want to join us. You can either register through the links, it is advertised on Facebook, or just send me a mail tomorrow and I will send you a direct Zoom link. So either way, join us on Saturday. Thank you very, very much for your time, guys. We appreciate it. And if there are any questions, you're welcome to pop them into the chat now. Otherwise, I will end off the meeting in a minute or two. And have a wonderful evening.
Okay, thank you very much, Tal. And also to all those who were able to attend, thank you so much for your support.